All right. So, Bismillahirrahmanirrahim. So, for today's lecture, we will cover network troubleshooting modules. In previous lesson, we already learned about network management and also network design. And one of the most important tasks for network engineer is troubleshooting your network problem during an issue, right? So, in my opinion, one of the hardest tasks to be accomplished by network engineer is troubleshooting your network issue, right? Because yes, maybe you can do configuration well, and you maybe can deploy your network in a fast manner. However, not all network engineer has a really good troubleshooting capabilities, right? Because when you want to do network troubleshooting, you are somehow becoming a detective. You need to first observe the symptoms, the network symptoms, and based on that, deduce from the evidence, from the symptoms, what is actually the issues happening on your network. Once you already understand what is happening, what is the problem, the core problem, only that, only then you can provide a solution in order to remediate or mitigate the issue, right? So that's why people are saying that understanding the problem is basically half of the solutions. Once you understand, really understand the core problem, only then you can administer and effective mitigation measures, right? So, in this chapter, we will discuss about several topics. So, first one is about network documentation, how it developed and used to troubleshoot network issue. And after that, troubleshooting process, troubleshooting tools, symptom and cause of network problems, and troubleshooting IP connectivity. So we try to discuss these topics in this module. So first thing first, network documentation. And my opinion, this is, I think, a single most important document for network engineer, especially when you are handling the network operation. Because without a proper documentation, it will make the troubleshooting process a lot trickier and a lot more longer, right? So that's why in a big network, in the operation of a big network, usually we have a two team. So first we have the deployment team or planning team, or somehow we call it as a rollout team, the one that responsible for rolling out a new network services or rolling out a new network coverage. So this means they are um, handling all the configuration. However, once they have completed their rollout task, they need to hand over that new network segment to the operation teams, right? The handout must include a proper network documentation. So that's mean you need to document what is the logical diagram of the network, physical diagram, the location. The logical diagram includes the VLAN ID, IP address, interface, all the configuration. So all of that must be included in the documentation so that when issues happen, operation team can easily see the documentation and start to understand what is happening, right? Without a proper documentation, it will become a nightmare for the operation teams. Okay. So it's provide so for network documentation, it provides an accurate and complete network documentation to effectively monitor and troubleshoot network. And the common network documentation, including physical and logical network diagram, network device documentation, and also network performance baseline, right? Baseline, that means in normal operation, what is the metrics, or what is the performance level when there is no issues, right? So that is what we call as a baseline. So this is the differences between physical and logical topology. At the left, we have what we call as physical topology. So in this topology, we are really want to know the physical connection and physical location of the network devices. So that's mean here, it will first label the interface name, right? The interface. And after that, it will the devices, for example, here located at where, for example, at rack 1, shelf 1, which building and which wiring closet. And actually, for the connection, if it is using a certain circuit number, so contoh, if you are using ISP services, right? So if you are using ISP services, usually the ISP will provide you with a circuit ID. So usually the circuit ID will be included in this physical topology. Okay. So in contrast, for logical topology, we really want to know the logical aspect, such as IP address, interface, interface IP address, interface name, subnet, VLAN, and if you have configured OSPF, you need to provide what is the area for that particular subnet. And also, if you are doing ether channel or port channel, you need to specify this interface is bundled into which port channels. So that is what we want in logical topology, right? So for network device documentation, for each of the devices, we need to provide a documentation. What is the device host name? What is the model? What is the location? The iOS version, the licenses, the interface, what is the IP being configured on that interface, the description tells us the interface is the purpose of the interface, whether it's connected to another switches or another router, and what is the routing protocol being configured on that particular interface. So this is example of network device documentation, right? Next is the network baseline. So baseline is determined, in my opinion, is in a normal operation, how the particular network devices or how the network behave without any issues. So there is a baseline. So it provides an insight into whether the network design can meet business requirement and reveals area of congestion areas in the network that are underutilized, right? So when you want to do a baseline, if you want to do a documentation, you need to determine what type of data to be collected, right? So first, we need to find what we want to collect in order for us to get the baseline. Usually for baseline, for network devices, we will first get what is the normal CPU utilization, the memory, and also the interface utilization. So that is what usually we are collecting to for a baseline. Then we need to identify a device and port of interest, right? If we want to baseline, we will not include interface which are not used, or maybe the interface which is not doing for production. For example, like your console port, we doesn't need to do a baseline on console port. And we don't do baseline on interface which is in the shutdown state. Usually we will do a baseline monitoring. This means we collect data from interface which is in the production. For example, in this diagram, we collect baseline from interface which is connected to another router or connected to another switch. right? And how long we want to determine the baseline duration. At minimum, usually it's 7 days long. We want to know, for example, when is the peak time? Peak time, that means the maximum utilization of the interface, for examples. So let's say when we are collecting data from 8 a.m. till 10 a.m., for example, the network utilization may be not that high. But during a peak time, from 10 to 2 p.m., where everybody is using the network to do their works, so there will be a spike in traffic. So when we collect for 7 days long, we know that what is the normal behavior of the network, right? And we conduct an annual analysis of the entire network or baseline in different sections of network on rotating basis. And usually, if you are having a good network monitoring system, NMS, right? Usually NMS will collect all of this data automatically. And later, if you want to do a baselining, you can use the data collected by the network monitoring system, NMS, to do your baselining, right? And it is also been done in the ISP domain, okay? So how are we going to measure? So we can utilize these different command in Cisco if we want to get a different information such as display, uptime, show interface. Yeah. So if we want to do manual baselining, right? So we can get all of this information. But like I said earlier, if we have a good network monitoring system, such as here, like this, all the baseline is basically automatically been collected. For example, here, the system already captured all of this software version, IP address, so it's already done. So we can check the historical data to do the network baselining, right? Any question? Can you see this screen that I'm showing to you, all of you right now? Right now,
Nampak sir.
all right. So for example here, the processor, we know what is the baseline utilization of the processor, and we know when time the CPU might spike, right? So we can do it manually or we can do automatically using NMS. Okay, so that is about network baselining. So now we're going to discuss about troubleshooting process. So when we want to do network troubleshooting, there is we must do it methodically. That means we must do it systematically so that we can have an effective troubleshooting of the network. Okay, so this is the normal troubleshooting procedures. So it can be time consuming, and different network and different problem has different setup, right? So the most efficient way to do troubleshooting is by doing systematically or in a structured manner. So this means we must have our logic flowchart to document our troubleshooting process. So for example, here we have stage one. So this is as example. First, we need to understand the symptom. After that, we isolate the problem. Then once after that, we can implement a corrective action. So if it's not fixed, then we need to repeat the step. If the corrective action is fixed, we can document what fix has been done so that we can prevent further issue in the future, right? So this is the 7-step troubleshooting process, right? So it starts with defining the problem, verify whether there is a problem or not. How are we going to know whether it is a problem or not? We must check with the baseline. So that's mean if we check from the baseline, previously, this network can access this network. Okay, then if right now, when people open a ticket or report the issues, when we check with the baseline, it's differ from the baseline. So previously, this network should be able to access this network, but now it cannot. So that means that is a problem. So we need to check with the baseline, right? Then after we have identified, yes, that is a problem, we need to know why it happened. So we need to gather information. What is the device which is terlibat ataupun what is device involved in this problem. So we need to know what is the host devices and identify how we can access the device or IP address. Then based on that, also we need to understand the symptom. Maybe sometimes when we do a ping, it simply cannot reach. Or we can do a ping, but the ping will maybe sometimes drop. Maybe we send a 10 ICMP packet, only 2 or 3 arrive, but another 7 drop. So that means there is another symptom. So we need to gather all the symptoms. Right? So based on the information which we have gathered, we need to analyze the information so that we can identify possible cause using network documentation, baseline, and knowledge bases or peers. And after that, we need to eliminate the possible causes. So that we propose hypothesis, test hypothesis, and solve the problem. Right? So this is a table. If let's say we want to gather information, we can also ask the end user which is reporting the problem, right? So this is example of question that we can ask the end user. So what does not works? So maybe they say that previously they can access certain system, but now today when they want to access the same system, they cannot able to open the system. That is example. Then what exactly is the problem? What are you trying to accomplish? So this is example of use question that we can ask the users, right? And this is common command that we can use in Cisco iOS to help for network engineer to gather information and gather the symptoms. So the most common one is using a ping, right? Whether the host is reachable or not using ICMP. Then after that, we can use trace route. So for trace route, we can know the path, the packet travel into the network. So, sorry, hold on. Right. So about the trace route, there is one issue that I know that when we do a trace route, first we can know when if let's say the network is unreachable when we are using a ping. So by having a trace route, we can know which of the network enable to forward the traffic. For example, like here. So let's say we want to reach, let's say customer or end user, they reported that they cannot access, for example, Amazon.com. So first we need to try to pick Amazon.com, for example. So here we know that Amazon.com will domain will translate it into this IP address. The method has reached. Hold on. Okay, so that means there is some issues. So we want to know which of the router enable to forward the traffic, so we can use this route. So we use the same domain or IP address. So let's use IP address. Okay, tracer. So if this is reverse DNS from IP address, it reverse to this nodes. So here we know that from my room router, it forward to UITM switches. Then after that, this will go into core switches of UITM. So it reverse. So that's mean in UITM part, everything's okay. It can forward the traffic. But let's see. Then it forward into UITM gateway into the internet. So it forward to which one? So we can check. We can do reverse DNS. So for example, we can use who is IP. So when we put this IP, we know the gateway is forwarding to which ISP. So it belongs to which one? Let's see. Is forwarded into certain IX internet exchange. But here, hold on. What is this domain? Let's use this. Shit. Maybe this is some sort of I'm not sure, but let's check another one. Let's check UITM gateway. Yeah, so this belong to UITM, and it forward into the, maybe this is my RAN. I'm not sure, but let's check again. How about this? Yeah, it's going to Tata Communication, which is, I think, a tier 1 ISP. So in my opinion, this is going to my RAN. This is part of Malaysian Research and Education Network. But not sure why it haven't registered the IP. I think this is part of my RAN. But anyhow, here this is example of traceroute. So we can know how the network go into Amazon.com, right? Okay. So we can also use telnet to know that whether the port is open or not. We can use SSH to try to connect to the devices if it supports SSH. And we can also use another command such as show IP route to see the routing tables. So this is a command that we can use to help us with troubleshooting. And we can also troubleshoot with a layered model where we separate the issue into different layer based on TCP/IP or OSI models. So in OSI, we have several layers. We start with physical, data link, network, transport, session, and presentation and application. So, for example, if we can ping the devices, so that's mean for physical data link network, there is no issue. But when we can ping, but we can access certain application on that server. So that's maybe because of transport or application issues. So that's how we can troubleshoot with a layered model. So we separate the problem into different layer because each layer has different symptoms, right? And this is different troubleshooting approach. So we can use a bottom up, which we can start from a physical layer, then we work into the layer, or top down from the application layer, from the simple problem to the physical layer, or we divide and conquer. We start at the middle layer and we test application and network problem, or we follow the path, substitution, comparison, and educated guess, right? So for educated guess, if you have a lot of experience, or if your peers have a lot of experience, sometimes by learning what is the symptom, they can already know, because based on their experience, they can say that, okay, I have this issue before, maybe this is what the problem is, right? So this is the guideline for selecting a troubleshooting method. So tadi tu we have different approach. So we can select what is the best method. So this um, diagram illustrate how we can effectively choose our troubleshooting method. First, we need to define the problem. So what is the type of problem? So if it software oriented, it's recommended if we are choosing a top-down method, where we start with, for example, if we can ping the devices, okay, we can ping the server, but we cannot access certain services. For example, if we open the website, when we want to send, we click login, then there is an issue. So that means there may be an issue with the software of the server. So we start from the application layer. So if, let's say, we cannot ping and we see that the interface is down, so that means we can start from bottom up method. So that is example how we can choose effective troubleshooting method. So troubleshooting process, we can use different tools to help us with troubleshooting. First, we have network management system tools, and also we have a knowledge bases and also baselining tools. Network management system tools are software which can help us to troubleshoot in more effective manner. For example, we can use Nmap, or we can use the tools ping, tracer, or we can use smooth ping, so that we can help us to troubleshoot more effectively. For knowledge bases, using the network vendor have some database which they already document what their other customer already experienced the issue. So we can go to the knowledge bases and we can start to gather information for that. For example, in Cisco, we can use Cisco knowledge base. So from here, it has a community which we can see what other people are asking their problem is. So from there, we can try to relate with our problem. Here, for example. So we can go from this Cisco community and we can find different issue, cannot ping, status down. So from here, we can gather information, how to troubleshoot, right? Okay. And baselining tool. I have mentioned earlier, one of the effective baselining tool is network monitoring system, which it can automatically collect all the baselining metrics or data. We can also use Wireshark. This is one of the network management system tools we can use to read the packet, so that we can know what really happening in the packet level, whether there is an ISMP reply, or maybe there is an issue on how the router encapsulate the data. So we can use Wiresharks, right? And for hardware base, we can leverage on digital multimeter, cable tester, so that we know whether the cabling, the physical cabling is correct or not. And for wireless, we can use portable network analyzer, where it can collect all the wireless information and know whether there is an issue with the wireless connection. And we can also leverage on syslog. So we have learned earlier during our network management module. We know that syslog will look everything which is happening on the network. So we can leverage on that so that we can know if anything happen, we can check from the log what is happening on the network devices. So we go into what is the symptom and causes of network problem. So here, one of the symptoms is performance is lower than baseline. For examples, earlier in the baseline, the latency, when we do a ping, the latency only 1 millisecond. Now, when a customer reported an issue, it has an issue when browsing the internet. But when we do a ping, the latency now is high. So maybe because there is a congestion. So based on that, that is a symptom, example of symptom that we can collect. Then after that, loss of connectivity, lower congestion, high CPU, and console error message. So this is an example of symptom. And also there is a power-related issue, hardware faults, cabling fault, donation, noise, or CPU overload. Maybe because of software issue, right? And there is also issue with data link layer or with the encapsulation error, right? This is layer 2 issue. And this is network layer troubleshooting, maybe because of misconfiguration of routing information, right? Network failure, suboptimal performance, general network issue, connectivity issue, routing issue, neighborhood issue. The OSPF neighbor is not up, and whatnot. This is because of ACL. So if you are configuring an external ACL, maybe the configuration is not right. So this means we cannot access certain services, right? So this is example of misconfiguration of transport layer. Okay, and this is interoperability with NAT. If we are having a NAT, so maybe it breaks end-to-end connectivity. So maybe we need to do some port forwarding in order for us to resolve the issue. Okay. So this is application layer troubleshooting. If let's say we can reach the server, but we can access certain protocol or certain services. So we can use telnet, or we can use nmap, so that we can know which port is open or not to troubleshoot an application layer issue. So if we want to troubleshoot IP connectivity, first, always if we are using bottom-up approach, always check the physical connection, whether the port is up or not. Or maybe if the port is up, maybe because of a duplex mismatch, where one side is half duplex, one side is full duplex. So there is a duplex mismatch. Or maybe we can check the data link and network layer addressing issue. Maybe the MAC address is not right, or IP address is not part of the subnet. Then after that, we verify the gateway. So this is if we are doing from bottom up, from layer 1 until layer 4, layer 7. Layer 7 here is DNS, for examples. Right? So if we want to do end-to-end connectivity tests, we can use ping or swap. So this is first, we verify the physical layer. We use the show interface command, or if you are troubleshooting from a PC, you can check the interface like this, whether it's connected to Wi-Fi or not, or whether your Ethernet connection is up or not, right? Then after that, we check for booklet mismatch, verify IP addressing, whether it's part of the subnet, maybe there is some misconfiguration, or maybe the MAC address is short, should not be assigned to the interface. Then VLAN issue, we check whether the port already been configured as part of the access VLAN. Then we check the gateway, whether the PC can reach the gateway. We can use show IP route to check the routing tables, right? This is for IPv6. We verify the correct path using a trace route, whether it's part of the routing table or the baseline or not. This is when we want to check the transport layer, we can use a telnet. So telnet, we can use it to check whether the port is open or not. Port 80, 443, port 21, we can use a telnet to make sure that we can get a reply. If we get a reply, that means the port is open. If not, that means the port is closed. Maybe there is issue with ACL, right? This is when we want to verify ACL. And this is if we want to verify DNS. We can do a ping with domain. Right, so that's all for troubleshooting. So we will do further after our Christmas break and year break, we will do lab. So we will do lab 12.5.13 troubleshooting enterprise network, so that we can know how to do step-by-step troubleshooting during our lab session. So hold on, let's see, it's open. Okay, so I want to give you homework. So please do this lab and we will discuss it during our lab session, right? So this, we will troubleshoot different issue with layer 2, with DHCP, routing and whatnot, right? We will discuss when we continue our lesson after our Christmas break, right? So, ada soalan tak? Any question about this module? Boleh? Any question?
Boleh, sir.
Alright. So, kalau tak ada apa-apa lagi, so I think that's all for our lecture for today. So, thank you for coming to class. So, please do your lab and we will discuss during our lab session.